XPath functions, and rather functions you can call on node sets might be a better term. Okay, so we've seen value of, and that's nice. I can go ahead and just grab what was directly in the database. Can I do a little bit of calling pass that stuff in the database to a function? And the answer is yes. So for instance, here's a valid XSL value of with a select attribute of not just height, but height divided by 3.28, and then round that result. Okay, and that's a reasonable thing to do. What does that do if you have a height that's in feet? Divide by 3.28, that's going to end up being meters roughly, and round to the nearest meter. So, yeah, how do you remember to convert feet to meters? It's roughly a yard, that's 3. And then if you really want to get that extra bit, 10% meter is 10% longer than a yard. So divide by a little bit more. Don't divide by 3, divide by 10% more than 3. Okay. Yeah, so I'll talk about some of the various functions you can have, but it's pretty straightforward, all we're going to talk about. I'll point out that we can do the same thing in SQL. With a select statement in SQL, we always think of just select and you give column names. That's about what we tend to do all the time in our database class, especially our first database class. But if you want to go ahead and do calculations on it, you can go ahead and here's a valid SQL statement. Select wage times round of 40 times weeks worked divided by 52. If weeks worked is a column and wage is a column, then round is a function that SQL knows about. Okay, and similarly here, as long as height is a field of the current node, or this here is an XPath, right? And then you can go ahead and do things like divide and round on it. Okay, so let's look at some of the functions. I have links to the overview of functions and the official reference and all that. And or and not. Okay, so I think last time I had a little question about how would you filter out all the nodes that are Greek or nodes that contain a Greek name or an English name. And so you can do something like this, ancient wonder / wonder. So that's going to give back a bunch of wonder objects. We're going to filter the wonder objects, so we're still going to get wonder objects, but we'll only include the ones that pass this one. All the wonder objects that have name / @lang equal en or name / @lang equal that. Okay, so we spell out and or not. Makes the Java programmers say, oh, I thought we should use ampersands, and makes the Python programmers say that's obvious. Why not use ampersands, by the way? Ampersand. Oh, because in XML, ampersand is already a reserved character, isn't it? So I guess they were kind of precluded, or at least it would be more difficult for them to do that. So, okay. Not is a function, not an operator. You say not, and you actually pass it the inputs, and an or are infix functions, which we call operators. Okay, multiplying, dividing, and subtracting. Use, of course, plus, dash, little star, and div. Why not slash? Okay, why not slash for division? Seems like it should be slash. Oh wait, slash in XPath already means this is not saying, hey, take the name and divide it by the language attribute. Not at all. It's and really slashes are really deeply embedded into this idea of XPath, so they really couldn't use slash for division. Okay, so to compare things, height equal this or that, equal sign, a single equal, not double equals, a single equal sign, not equals, greater than. Now you might think, oh, Barland, you have a goof up on your page. You've over sanitized your HTML one too many times. You mean a greater than character. I do not mean a greater than character to use greater than. If you want to compare if one thing is bigger than another in XPath, you don't use a greater than sign. Use ampersand GT semicolon. Why don't you use a greater than sign? We're inside an XML document, and greater than signs are a special character for XML structure. Okay, yeah, greater than or equal, ampersand GT semicolon equal sign. Okay, fair enough. So here's a find things, you could say loop over all the ancient wonders / wonder where height is greater than or equal to 100 or something like that. Okay, so let's go ahead and look at a page that does that. We got the tall wonders of the world. We're actually using 107 feet rather than 100. So we get the pyramids, the lighthouse, the mausoleum, and the colossus. And down here we have the history, and we get the pyramids and the mausoleum and the lighthouse. Wait, what happened to the colossus? And at the bottom of the page, no colossus of rows. Let's go look at the code, see why one is included in one list and not the other. The XSLT for that. Look, here's 107. Here we are. Notice that my source code actually has an ampersand GT semicolon here. When that's being displayed, rendered inside the browser, which is where we're looking at it now, it's showing up as a greater than sign. But in the source code that I had to write, it's ampersand GT semicolon. Okay, yeah, so I had ancient wonder / wonder height bigger than 107. And then I had another one where I went ahead and did the histories. And here I just said greater than 107. Oh yeah, so as a testing issue, we always want to, again, test cusps, dividing points of ranges, make sure we're getting things just right. So anyway, so those are examples, with the caveat that when I type it in my source, I actually type it in with the ampersand GT semicolon. If you're interested in something I glossed over on a previous lecture and I'm not going to be asking you to do, you can look at the apply templates and see here, oh, we're actually doing, it's not a for each loop where I include the body in here. I use apply templates on this particular node set. And then the apply templates comes down. I have a template here to process a wonder, and that gave me the actual table row, etc. So, okay. But that's neither here nor there. The point of this is we can go ahead and when we do the filtering, we can include Boolean conditions using greater than. Okay. What else? Math operations. Sure, we can do math. Okay, this is actually one of my more favorite things here. We have the same table. I've added one column to the table, the years standing. Okay. How do we calculate the years standing? Colossus of Rhodes only stood for 56 years. Great Pyramid still standing. This is, you know, almost 4,600 years and counting. So, okay, how do we actually do the math on that? Oh, if we go ahead and look in our database, let's look at do a show source. We can see that there's a year built, 282 in the BC era, and year destroyed, 226 in the BC era. So it's negative 282 to negative 286. You take the year destroyed minus the year built. Okay. Any little glitches with years, by the way, when computing years? What if something was built in the year 2 BC and destroyed in the year 2 AD? That sounds like it should be 2 minus negative, it should be 4, or something like that. Unfortunately, there is no year 0, and that kind of goofs that calculation up. So if you actually cross the BC to AD era, be careful to actually subtract 1 year from what you think it should be. So, okay. And we can look at the code that actually goes ahead and computes the years there. And again, this is from the textbook, and they are a little bit maybe sloppy in how they calculate this. Let's look at this. If we had a really good test database, remember this XSLT code should work for any database of wonders. And if the world votes in a new wonder that had been made in BC and destroyed AD, yeah, that's going to be an issue here. So here's how they actually do that arithmetic. When the year destroyed was BC, well, if it was destroyed BC, I guess it had to be created BC. So we can go ahead and do a minus of history / year destroyed. Why minus? Because that number was listed as 282, but it meant negative 282. So year destroyed minus year built, put them both in negative because we know they're both BC. Otherwise, if the year destroyed was not BC, okay, then we can go ahead and do this here. By the way, I should just say this is all things that actually have a year destroyed. If there's no year destroyed, it will test as 0. So I don't like that necessarily, but okay. So if it wasn't destroyed BC, it was destroyed AD, and here's some built-in assumption to the code that the year built must have been BC. That's not really in the database. That's extra knowledge being thrown in there. It's an invariant that doesn't actually maybe hold. So, okay. And otherwise, we take the current year, or maybe the current year from 4 years ago, and subtract that. And then subtract 1, and that's what we do. I had to add that into what the book had to take care of the fact that there was no year 0. So, okay. Anyway, that's just, you can go and look at that, and look at that. That's how we computed the age of each wonder. Count. And so remember, all these functions actually work on node sets. And like we mentioned, value of, if it has a node set that's more than one element, you're going to be kind of in trouble. It's going to choose one of them at random, perhaps. Same with these numbers, these numeric things, okay? Because really this greater than is working on node sets. The height is a node set. Better be just one, otherwise we'll choose probably the first one, but again, can't count on that. Here's a function that really makes it clear we're working on an entire node set, the count function. You give it a node set, it returns how many there are. So that's kind of cool, and this is another page that I enjoyed looking at and what was done here. The wonders of the ancient world. Of these wonders, 4 were destroyed by earthquake, 2 were destroyed by fire, and 1 is still standing. Well, that's pretty cool. How did we actually compute that? We actually had a program that read that out of the database, and part of it's because in the database there is a reason for how it was destroyed. So how destroyed earthquake. So that information is in the database. We need to go ahead and count it, though. You can think about how to do this. How we go get an expression for the number of wonders destroyed by fire. Go ahead and pause and see if you can actually do that. Hint, we'll use filtering, and then the count method that we just saw. Okay. So going and looking at that, how did we actually work it? We work it by taking our cat and saying, hello, cat. Hey, kitty, are you trying to walk on the keyboard? Yeah, you see, you're not even looking at the camera. You're ashamed of what you're doing. Not even looking at the camera. And trying to bite me. We're going to go ahead and set you outside here. Okay, now they've had the time to think about how to do this, the filtering and everything. Were destroyed by earthquake. So here's how I like this. This, I think, is the right way to do it. We'll do a count of, we'll look at ancient wonders / history / how destroyed. We'll look at all the how destroyed nodes, and then we'll filter those for the how destroyed equal earthquake, okay? And then we will count the result of that filtering. So we found all the nodes, we filtered them with square bracket, and then we called count on them. Okay, that sounds good. Here's a cheesy way of doing this, a hacky way. Again, what is a hack in computing? If you're talking about coding, a hack is code that is not the right way to do something but happens to work, but it's not just the right way. So what is the hack that was in the book's original code? They count, they didn't want to write so much. They just count, hey, look for how destroyed's anywhere in the entire table. It doesn't have to be inside a history tag. So if we go and change our database and add a how destroyed inside inside other subtags that don't refer to the wonder, they're talking about other things. We might have an image tag, and then the image file might have been destroyed, and we have how the image file was destroyed with inside the main image tag of something else. Well, tough luck for this code, because this code would be wrong then. They say, hey, / how destroyed, find all the whole how destroyeds in the entire document, filter them for equal to fire, and then count. So how many were not destroyed? This one's kind of cool. Grab all the wonders and subtract all the how destroyeds. Okay? So again, I don't like the / wonder and the / how destroyed. As a count of ancient wonder / wonder, that's exactly what I want to count. If there are other wonder tags that are nested in, if you have a, one of the ancient wonders, you have a list of adjacent landmarks, and one of those adjacent landmarks is a wonder, well then, again, this code wouldn't work anymore. But enough of that. So these are just examples of how you can be a little bit creative and actually come up with really interesting pages that go ahead and get you what you want to have in this page. So kind of fun. Yeah, kind of neat. Yeah, programming is fun. I forget that every now and then. And then I remember. Okay, cool. I forget that every now and then I remember, and then I come back to the video and forget it again. Counting nodes. Here's a bunch of boring functions you can use. Format number. Okay, and you can look at the documentation, but if you want to go ahead and have numbers with leading zeros or commas or use parentheses rather than a negative sign to indicate a negative number, etc. Yeah, you can do all sorts of things like that. You can look at the example if you're interested. Ceiling, floor, and round. I mentioned these partly because round is one that people think of in all languages. Ceiling and floor are often very helpful functions that you want to use, and they're often overlooked. So I'll just point out ceiling and floor in this language and all languages. And usually when I'm talking about all languages, I'm talking about Java, I'm going to say, hey, in addition to having math.round, you have math.ceil and math.floor, and you have math.min and math.max, which are often functions that can save you an if statement in the middle of your code and tighten up your own code. Hey, take the maximum of two numbers. I'll give you two numbers, return me to the maximum. There isn't a max or a min in XSLT, so that's annoying. A little bit odd. So here is how, if you really wanted to find the oldest wonder or the tallest wonder or something like that, how could you do that? Here's my hack, and it's absolutely a hack. I'm going to loop over all the wonders and then have a little if statement if I'm at the very first one. Okay, and we'll talk about position in one moment. Yeah, so this is I'm going to loop over 1,000 things, and inside my loop is a if index equal 1, do something, otherwise. So I handle the very first one, and then I loop through all the others doing nothing. And that's, yeah, oh well. Okay. There is string concatenation. You can concat as many strings as you like together and get one string as a result. There is substring. Okay. Substring follows, it's not quite Java's convention where you give the start index and the end index. It's more the PHP convention. You give the start index and the length of the string you want to grab. I should mention, by the way, that XSLT is not good about protecting yourself against errors. If you ask for more characters than there are on the string, it's not going to give you an error. It'll be like Python in that regard. It will say, oh, you just must want to the end of the string. Clearly, that must be what you meant. Okay, substring after. That's kind of a cool function. Go inside the first one, look for some other string, and give me everything after that string. So, substring after of Gonzo the Magnificent. Give me everything after the comma. That would return space the Magnificent. Okay. So, of course, usually you wouldn't hard code the string. The string itself would be from some other XPath expression or something. Okay. Contains. Does one string contain another? That's a handy thing in a lot of language. Starts with, I'm glad that's built in. This is one that I often write myself in language after language after language. I have two strings as one or prefix of the other. So starts with and ends with are handy functions to have. I mentioned before translate. Let me introduce it more formally now. Translate. You give me a big long string. Okay. You give me a series of, say, 5 letters that you want me to change, and the 5 letters that you want each of them to get changed to, respectively. Okay, so here's an example. Translate the current node, the contents of the current node, text node presumably. Change any E's to 3's. Oops. Change any S's to dollar signs. Oh, we're getting cooler and cooler. Change any Z's to 2s. So it does not say find an occurrence of this all 5 characters in a row, replace it with those 5 characters. It's not a substitute. It's a translate one character, a character for character. Okay, so just be aware of that. And this string had better be the same length as that string. If not, you won't get an error. Again, XSLT is a little bit permissive about that. It will do something even if you would wish it would have given you an error because it should have known you goofed up. Okay. Finally, the function sum. Sum takes an entire node set and treats them all as numbers and adds them all up for you. So what is this expression here? Sum of ancient wonder slash height. That's a node set of all the heights. Div is divide, and then count of ancient wonder slash wonder. Okay, that's the average height. Okay, so you can go ahead and do that. And we have an example where we end up use that exact code to get the result of an average height down here, and we even put in the height in meters as we went. So, okay. So those are different functions we can use. XPath functions on node sets. Do you want to write your own function so you can call it repeatedly? Of course, we're programmers. That's what we're built to do. Yeah, not an XSLT1. And XSLT2 doesn't really have wide support, so yeah. Okay. Oh well. I'm going to end with 2 kind of weirdo functions. There we are. 2 kind of weirdo functions. Position and last. Why are they? They're not really that weird. Position takes no inputs. That's why I think it's a little bit weird. It looks like it takes no inputs at all, but it says, hey, for the current node, tell me what number, among my siblings, what number am I? I'm the oldest sibling, number 1, or the second sibling, the third sibling. Okay, so among the node set containing me, what is my position? Yeah. So that's kind of weird. Last goes ahead and is essentially how many nodes are there in the current node set of all the siblings here. So these 2 functions are odd in that they don't, it looks like they take no input. They use the context as part of the input, which again is sort of against the spirit of organizing everything as XML. So, oh well. Fair enough. We'll just realize that. And we went ahead and used that. We saw an example already. I mentioned something we're using to find the maximum. We filter on position equal 1. Okay. You can go ahead and do that. Here's something kind of cool. The ancient wonders are something, comma, something, comma, something. How are we getting a whole list of the names followed by commas? Oh, yeah, that's that for each loop. Okay. Temple of Artemis, Mausoleum at Halicarnassus, comma, and Lighthouse of Alexandria. We got the word and stuck in there in the middle of, that wasn't in any other part of the loop. How do we actually do that? And that's easy enough. We went ahead and have in our for each loop, here's the for each loop. When position is last, so we went ahead and took out the name. Okay, that's what this did here. Value of select equal dot, take current node, because we were looping over all the names. And then I had, hey, I had to choose when position is last, add a period. Otherwise, if we are the last -1, do a comma space and. Otherwise, do a comma. Okay, so yeah, pretty straightforward. You can use position and last to go ahead and get nuanced behavior. And I think that is all to say, except for sometimes we'll see something, you'll see things in XSLT, or XPath rather. Okay, you'll see things like ancient wonders / wonder square brackets 3. And what does that square brackets look like? This looks like, square brackets looks like an array lookup. And you might, if you just came across this and were learning XPath by just looking at XPath expressions, you might well be fooled into thinking that there are arrays in XPath. There are not arrays in XPath. Square brackets means filter, right? So how can we filter position equal 3, sorry, single equal to compare? That would make a lot of sense. It turns out that when you just write, if you just have square brackets with just a number in there, it's shorthand, it's syntactic sugar for this thing here. Okay, so that's fine, that's cool. Just don't start thinking there's arrays in XSLT, there's not. It's just calling the position as a shorthand. Okay, sounds good. We can do a lot of fun stuff with XPath, and again, you'll see XPath in the XPath libraries in Java, XPath libraries in Python, all sorts of different places you can use these. XPath is a great domain-specific language to be able to talk about node sets from a tree and do basic operations on them in a very convenient, concise way, rather than saying having to write a Java program that looped and iterated and found the right things. So yeah, XPath. Thumbs up from Barland.